Today we're going to be subtracting fractions. We're on lesson 9-4, page 345 in your volume 2 Envision math textbook. Yesterday was adding fractions. Again, today is subtracting. We're going to use fraction strips or area models to subtract fractions with like denominators. That's our key again, as it was yesterday. Like denominators means that we are using the same size parts of a whole. So yesterday I showed you the fraction strip of this, which only fits in the frame if I do it sideways like this, but we've got this whole is divided into 1, 2, 3, 4, 5 equal parts. So if we were to add or subtract, we're going to need to keep the same size parts of the whole. So we would have to use fifths for adding or subtracting, as we learned yesterday or today. Let's look at solve and share. Mr. Yetkin uses 4/6 of a sheet of plywood to board up a window. How much plywood is left? Solve this problem any way you choose. So what I think I'll do is I'll make an area model. And I'm going to divide my strip into 6 equal parts because we are dealing with parts, 6 equal parts. So that's 2. That makes 3, 4, 5, and 6. So we have 6/6 of a sheet of plywood, which means we have a whole sheet of plywood, and each one of these is 1/6. If Mr. Yetkin uses 4/6 of this board, 1/6, 2, 3, 4, 4/6. How much plywood is left? Again, we started with 1, 2, 3, 4, 5, 6 equal parts that weren't used. 6/6 is a whole. We started with one whole, which we turned that into 6/6 because we're going to be taking away a fraction of it. So 6/6 minus 4/6, we already know we have 2/6 left over that have not been used. Again, we can look at it like we did with the addition yesterday. We can simply keep our denominator the same, that never changes when you're adding or subtracting fractions. We look at the numerators, the 6, and we take away, subtract 4. 6 take away 4 is 2, and therefore we have 2/6 remaining. Okay, the model I think helped. So let's see it. Look back, be precise, explain why 4/6 is subtracted from 6/6 to find out how much plywood is left. So we started with a whole, and we were taking away 4/6 of it. In our heads and minds, that isn't something we can really solve in this fashion. So what we did was we divided the board into 6 equal pieces. 6/6 is one whole. We took away the 4/6. So that's why we subtracted, because 6/6 is our whole board that we started with, one whole board. And we just made those like denominators because we learned yesterday our pieces have to be the equal, or parts of the whole have to be the same. And so therefore we made 6 equal parts of 6 so that we could take away 4 of them. All right, you're going to do a little more of this through the visual learning video, again with the fraction strip, and then again with a number line on visual learning with page 346. If you turn to 347, we'll look at another example using the fraction strips. So we've got a whole. If we count, we've divided them into eighths. So we've got 1, 2, 3, 4, 5, 6, 7, 8 eighths. We just proved equals a whole. So we've divided them into 8 equal parts. But we have 2 of those, 2 wholes, what we're starting with. Because 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm getting ahead of myself, that we're going to have as our answer is more than a whole. So let's take a look at what we have. 11/8, the numerator is greater than the denominator. We know that only 8/8 makes a whole, so we have 3 more parts that we started with. So they've kind of already taken those away. But really what this problem would look like is this is also shaded in. These 2 parts are in here to make our 11/8. Okay, if we added those in, that would be 11/8. Now if we take 2 of those away, that's what they're showing here. Take 2 of those 11/8 away. How many do we have left? Well, 11 take away 2 is 9, and we still have them into 8 equal parts. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 eighths remaining. So to find 11/8 take away 2 eighths, you use 11 1/8 fraction strips to show 11/8. You take 2 strips away, so you're subtracting. So 11 take away 2 is 9, or we can count what we have left. We can check ourselves whenever we are subtracting. We can take the answer we get and we can add it to what we took away. So 9 plus 2 should be the 11. Now what they've done is they are going to show you the answer 9/8 in a different form. Remember, 9/8 means more than a whole, because we know that 8/8 is 1 whole. Plus 1 more would make the 9/8. So if we've got a whole here and 1/8 left over, our 9/8 is the same as 1 1/8. So this is called a mixed number. And this is the fraction that it came from, 9/8. You can show your answer as the fraction or the mixed number. All right, again, we won't do number 1 because that's referring to the page you're going to do with the visual learning video. But let's take a look at numbers 2 through 5. Do you know how? Use fraction strips or other tools to subtract. So again, we can just draw a little picture of this. Thirds, so we have to divide into 3 equal parts. We're going to start with 1 out of those 3, 1/3. If we take away 1/3 from the 1/3 that's shaded, what do we have left? How much do we have shaded left? That's right, we would have 0. If this 1/3 that was shaded is taken away, removed, we have no more shaded. That one's a little tricky. So let's look at 5/5. So 1, 2, 3, 1, 2, 3, 4, 5 equal parts. We're pretending that they're equal, and we are going to shade all 5 of those, 2, 3, 4, 5, and we're going to take 2 of those away. Let's take the last 2, 1, 2. How many are left that are shaded? 1, 2, 3. And how many are all together? 1, 2, 3, 4, 5 still. So our answer would be 3/5. So let's check. Our denominator stays the same. It's a 5 because it's still 5 equal parts. If we started with 5 and we take away 2 of them, 5 take away 2 is 3. So that would check for our numerator. Number 4, 7/12, take away 3/12. 12's an even number, so I like to do my drawings in even. So right now I have 4, so that means each one of these is going to be thirds, because 4 times 3 is 12. That's how I know. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have to pretend they're equal parts. Some look a little bigger than others, but let's pretend they're equal. 12 equal parts. We start with 7. 1, 2, 3, 4, 5, 6, and 7. If we take 3 of those away, 1, 2, 3, how many are still shaded? How many do we still have? 1, 2, 3, 4, And remember, we still have 12 altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would equal 4/12. Looking at it as just subtracting numerator, 7 take away 3 is 4, checks, and we keep the same denominator. Last one, number 5, 7/8. One, 2, 3, 4, 5, 6, 7. Take one of those shaded ones away because we're taking away 1/8. We're left with 1, 2, 3, 4, 5, 6. We're still shaded out of 1, 2, 3, 4, 5, 6, 7, 8. 6/8. All right, you are going to do independent practice numbers 6 through 14. Same thing, you draw a picture, or you can simply, if you've gotten the hang of subtracting the numerators, keeping the denominator the same, and understand why that is. And then 21 and 22 in the back. These will be done after you do your visual learning video, along with page 346 in your text.